Have you ever wondered what an over-engineered keyboard looks like? Well, today you're in luck, because I have two of them here, and I'm going to go over 8 details that will make you doubt the sanity of the design team. Let's rip them apart. Actually, for the most part, I won't need this. I will only need a screwdriver and a keycap and switch puller. But I will need the saw to show you how the most over-engineered part of these keyboards is made, the pad pads. So make sure to stay until the end to find out. One of the party tricks of the Dygma Race 2 is that it looks like a normal keyboard, and then you can split it and then put it back together. But in order to achieve that, we had to design an over-engineered mechanism that is able to connect both sides, and you can still detach them easily, and you can even adjust it. Let's take a look. As you can see, there's a succession of male and female pins that connect to each other. There's also magnets inside to help keep the sides together, and on top of that, you can also adjust the strength of those holes. So with those screws here that are barely visible and a screwdriver, you can tighten and loosen the joint. So it's either sturdier, like I have it right now, where you cannot, you need to wheel it out of position, or you make it looser so it's easier to snap it apart. Now let's talk about one of my favorite things, the thumb keys. Most ergonomic keyboards use normal keys for the thumbs, but not us. In the Dygma Race 2, it's a bit less obvious. You can notice that these keycaps are convex instead of concave, like most keycaps. This is important because you type differently with your fingers than with your thumb. Your fingers type like this, while your thumb does like this, hitting with the whole surface. So if this is concave, you hit the edges of the keycap. When it's convex like this, it's a smooth surface all around, and the edges are also smooth, so it's much nicer when you hit it. Another important detail is that there is 2 rows of thumb keys, and each one has a different height. The top row uses normal MX switches, like any other key, and the bottom row uses low-profile switches, so the key is lower. This is important because if both keys were the same height, you could not press this one without pressing the bottom one. But now you can press these 2 without hitting the bottom ones, and you can hit the bottom ones separately. We achieve this by having low-profile switches for the low-profile keycaps. But if there is a keyboard where we over-engineer a thumb cluster, that is the Dygma Defy. Here we took to the limit how many thumb keys you can put into a thumb cluster. The switches are really close together, and the keys are as small as possible without hindering your ability to distinguish them without looking. The key to achieving this is these separations here, which you can see form like a little V. That way your thumb kind of notices those little gaps when scrolling through the thumb cluster and rapidly recognizes the position it's in. We also have homing keys here, so you can find the base thumb key. Just as on the Dygma Race 2, we also have low profile switches in the bottom row, so both rows have different heights. You can press the top row like this without having to arc your thumb. We even chamfered this thumb key here because it makes it so much easier to transition from the low profile keycaps to the normal profile keycaps. You can even just slide your thumb from one to the other. If you're interested in the design of the thumb keys, we have a whole video about them that you can check out here. Another thing that we over-engineer is the tenting mechanism. Instead of using 2 sheets of metal that move on a hinge like most ergonomic keyboards do, we design a system of aluminum legs with rods and different angle positions in the base, so you could flip them and make the tenting disappear when you don't want to use it. But that's not the over-engineered part. If you want to know the whole story about the tenting mechanism, we have another video that you can also check here. But I want to show you a small detail that I really like, and that is how you take these legs out. You would think that you would just grab it here and take it out. But our engineers thought of a better way. There is a recess right there where you can put your finger and take it out. You can see that here is not just the leg, but we created a little lip so you can take the leg out intuitively without having to grab it with both hands or exert pressure to the side. On the Dygma Race 2, we faced another problem. The rods are so close to the leg that there's no way to put your finger there. So what did we do? We created a recess on the side of the base so you can put your finger in and take the leg out. Both solutions overcomplicate the molds of the base or the tenting legs, but we think that those little details improve the UX when using the keyboard. So we believe that it was totally worth it. Now that we're looking at the back of the keyboard, I want to show you two more little over-engineered details. One of them is this little ramp that you can find here. We could have made it straight like this, and that would have made the mold much easier. That ramp is there so the Neuron, which is the brain of the keyboard, and also the Bluetooth adapter can slide right in. And it's also much easier to take out. The other detail that I was talking about is these 4 holes that you can find here. These are M3 screw holes that you can use to attach things to the keyboard. We have designed an adapter pack that screws to these holes and has a 1/4 screw hole, which is the standard for camera gear. That way you can then attach the keyboard to a tripod or maybe some camera arms. In fact, we have also designed those and they are available at our shop at dygma.com/arms. With those arms, you can adjust the keyboard like you want, even more than with tenting. So maybe you can have the keyboard here, or even attached to the arms of your chair. If your chair has arms, not mine. You can also design crazy things, like for example, we 3D printed an accessory that lets you put the keyboard in a holster, like if there were guns in the Wild West. I even attended a convention with those. Now let's talk about my absolute favorite over-engineered detail on these keyboards. And that is the RGBW LEDs. LEDs on all keyboards are usually just RGB, meaning that it has a red diode, a green diode, and a blue diode. So if you want to create white, you need to mix all 3. And if they're slightly unbalanced, you will get a bluish white, a reddish white, or a greenish white. And we don't like that. We wanted pure white on our keyboards. The problem with these special LEDs is that they're not mounted like normal LEDs. So we had to redesign the PCB inside the keyboard. Let me show you. So here's the PCB. Normally, LEDs are what is called reverse mounted, meaning that they are placed in the back of the PCB. This is the top where the switches go, and this is the bottom of the PCB. Here you see the sockets. This is where you attach the switches, and normally the LED goes right there, as you can see on the PCBs of the OG Race, the previous keyboard to this one. But it turns out there is no reverse mounted RGBW LEDs. They are only available top mounted. That means that they have to go on the top of the PCB. And that presents 2 major issues. One of them is that with the LEDs being on top, when you place the switch and press the key, you might damage the LED. And on top of that, the LED adds 0.6 millimeters, which means that the keyboard would have had to be a little bit taller, and we had spent months making it as thin as possible. The solution was completely redesign the PCB to make it 0.6 millimeters thinner. It was 1.6 millimeters on the original Dygma Race, and then we made it 1 millimeter here, so super thin. And we added this 0.6 millimeter felt that surrounds the whole PCB and lets just the holes for the sockets and the LEDs. So the combination of reducing the PCB and adding that felt that protects the LEDs solve the issue. But you can understand how over-engineered this turned out to, because on top of that, we now had to assemble the PCBs on both sides. Normally, they are only assembled on one side with all the chips and the sockets being here, and there's nothing on this side. But now we also had to assemble it on this side. And now that I have the PCB here, I want to note out another detail that is related to the Thumbkeys that we mentioned earlier. This small PCB that is soldered to the main PCB is here for the low profile switches, for the low profile keycaps. And you can see that it's slightly above the PCB because the distance from the top panel to the PCB has to be different for normal switches compared to low profile switches. So we ended up with this complex PCB compared to what you would normally find on a standard keyboard. All because we wanted pure white. Now that I have the top panel here, I want to show you a couple of little details. One of them is this little recess that matches the position of the battery here. And that is there just in case the battery delays a little bit when being used. Normally batteries get a little bit hot when being used and they can expand a little bit. So that is there to leave a little room for expansion and allowing us to use the bigger battery possible. And another thing I wanted to show you is the complex recesses that you can find here in the top panel. These are for the low profile switches, and you can see that there's a little recess here and 4 recesses on the top. That is because low profile switches have a different clipping mechanism than normal switches. Normal switches clip north to south and they have these little tabs on the top and the bottom, and low profile switches clip from west to east. And you can see small clips here where those recesses are in the top panel. Looking at the top panel, you might also be wondering why do we have 3 magnets here? And that is for the magnetic pulp pads, which is what we're going to see next. I know you've been waiting for this, so let's bring the saw and cut this in half because it's really interesting what's inside. In the original pulp pads from the OG race, this was just self-adhesive silicone with a TPU cover of synthetic leather. But these new pulp pads have many more parts. So as you can see in this cross section here, the pulp pad is made of several layers. First, we have a thin layer of anti-slip in the back, which is glued to the base. The base is made of plastic and is what gives the pulp pad its rigidity and its shape. Then we have a layer of denser foam, another piece of plastic that gives it more rigidity, and finally the silicone that gives it that squishy feeling and nice feeling when you place your palms on it. And wrapping it all, there is a layer of synthetic leather, which gives it this nice finish. And sandwiched between all those layers are 3 magnets that match the magnets that are on the base. So we have 1 here and 2 here that you can't see. The base has recesses, so the magnets fit exactly there. And then you place the pulp pad on top. In fact, there's 1 more layer that you cannot really see here, which is this double-sided special tape that is cut to the shape of the pulp pad. So this is stuck to the base that way. So to make pulp pad, we need 1, 2, 3, 4, 5, 6, 7, and 8 layers. And that's it. That's what makes an over-engineered keyboard. Let me know in the comments which is your favorite detail, or if you think we've gone too far and we shouldn't complicate things so much. But be careful, I'll be reading. I hope you liked this video. Until the next one.